You know, every single day you click on links, you type in web addresses, and poof, a whole world of information just appears on your screen. It feels like magic, right? But it's actually one of the most incredible high-speed journeys in the modern world. So today, let's dive in and unpack the magic behind that simple click. Seriously, think about it. In the fraction of a second, the blink of an eye, between you hitting that enter key and a website loading, this ridiculously complex conversation happens across the globe. We're going to follow that conversation step by step and really see the hidden machinery that makes the web work. All right, so here's our game plan. First, we'll look at the magic trick itself. Then we'll find the internet's secret address book. After that, we'll see how a connection gets made, how your browser even asks for a page, what the server says back, and finally, how your browser becomes an artist to put it all together for you. Let's get into it. Okay, first up, let's deconstruct this magic trick we do all day, every day. It's this high-speed process built on some seriously clever engineering and a bunch of rules that everyone agrees on, and it creates that seamless experience we totally take for granted. So this is the first big hurdle. I mean, the internet is a massive, sprawling network of millions and millions of computers. When you type in a name like example.org, you're not really giving your computer much to go on. It needs a specific, unique address to find the one server in the world that has the website you want. So how does it solve that problem? Well, the internet has this giant worldwide directory service. You can really just think of it as the planet's address book for websites. And this system is called the Domain Name Service, or DNS for short. And honestly, the phone book analogy is perfect. You know a person's name, but you can't just call them without their phone number. It's the exact same thing for the web. Your browser knows the website's name, but to actually connect to it, it needs a specific string of numbers. And this is the core translation that has to happen. See, we're good with names. Computers, they only care about numbers. Every single server on the internet has a unique numerical label called an IP address. So DNS is that crucial translator, turning the friendly name we type into the IP address the computer actually needs. Okay, awesome. We have the address, but we can't just start shouting information at it. We need to open a formal, reliable line of communication. It's just like making a phone call. First, you have to make sure the other person is actually picked up and is ready to talk. So at the most basic level, you've got the Internet Protocol, or IP. Its only job is to chop our data into these little chunks called packets and then slap the destination address on them. Think of it like a standard postal service. It just sends the letters out, it doesn't offer any tracking, and there's no guarantee they'll all arrive, or even show up in the right order. Now, for something as important as loading a web page, best effort just isn't going to cut it. And that's where TCP, the Transmission Control Protocol, comes in to save the day. It works right on top of IP and adds that crucial layer of reliability. So it's less like standard mail and more like FedEx with a tracking number. TCP makes sure a stable connection is made and guarantees every single packet gets there and that they're all put back together in the right order. So how does it set up this reliable connection? With this super quick, polite, three-step process called the TCP handshake. It's basically your computer sending a message saying, "Hey, you there, can we talk?" The server replies, "Yep, I'm here, can you hear me?" And your computer confirms loud and clear. And just like that, the connection is established. This whole thing happens in milliseconds. It's incredible. Okay, the line is open. We know the address. The connection is stable and ready to go. Now it's time for your browser to actually ask for the website. And this is done using another set of rules, another protocol, called the Hypertext Transfer Protocol, or HTTP. An HTTP request isn't just a vague, "give me the page." No, it's a very precisely formatted text message. It has a start line saying what it wants, then a bunch of header fields with extra info. Like a header might tell the server you're using Chrome, or that you prefer websites in English. Then a blank line at the end signals, "Okay, I'm done asking." And here's the key. Almost every single time you type an address or click a link, your browser is sending what's called a GET request. It's the most common command in the whole HTTP language, and it's as simple as it sounds. It's your browser just saying, "Please get me the content for this page." So the server gets the request, it understands exactly what your browser wants. Now it's time for the other half of the conversation, the server's reply. And that, of course, is called an HTTP response. And just like the request, the response has a very specific structure. But after all the formal bits and the blank line, that's where you find the most important part, the body. This is the payload, the treasure chest. It is packed with all the raw code, HTML, CSS, and JavaScript, that is about to become the web page you see. That status line is also super important. It has a 3-digit code that tells your browser how things went. You've definitely seen these before. A code in the 200s, like 200 OK, means success, here's your page. A 400 code, like the infamous 404 not found, means you messed up. You probably typed the wrong address. And a 500 series code means something went wrong on the website's end, not yours. We are on the home stretch. The data has traveled all the way from the server and it has arrived at your computer. But right now, it's just a big block of code. The final piece of magic is performed by your web browser, which has to act as both an interpreter and an artist. So your browser's main job is to take that raw code from the server and render it, which is a fancy way of saying it turns a jumble of text into the visual, interactive web page you actually see. And this incredible transformation happens thanks to 3 core technologies working together. First, you've got HTML. Think of HTML as the skeleton of the web page. It doesn't care about pretty colors or fonts. Its only job is to provide the fundamental structure. It uses tags to say, this block of text is a headline, this is a paragraph, and hey, put an image right here. Next up is CSS. No, if HTML is the skeleton, CSS is the fashion designer that dresses it all up. It takes that raw HTML structure and applies all the visual styling. CSS is what defines the color of the text, the font it uses, the layout of the columns, that cool background image. It controls the entire look and feel of the site. And finally, there's JavaScript. This is what makes the page dynamic and interactive. So if HTML provides the bones and CSS provides the style, JavaScript provides the brains and the muscle. When you click a button and a menu animates into view, or when a photo gallery updates without reloading the whole page, that's JavaScript making it happen. So let's recap that entire journey super fast. Your browser uses DNS to find the server's number. It uses TCP to make a reliable call. It sends an HTTP GET request asking for the page. The server sends back an HTTP response with all the code. And finally, your browser uses HTML, CSS, and JavaScript to build the final interactive page you see, all in a flash. So there it is. From a single click to a fully rendered website, it's this incredible, high-speed dance of protocols and technologies that all happens in the blink of an eye. But, it's important to remember that this whole process is never really invisible. Every request for an address, every piece of data sent, it all leaves a tiny digital footprint. And it kind of makes you think, what kind of trail are you leaving behind? And what story is it telling about you?